Hey everybody, welcome to another con support video. This time it's on function rules from equations and how to do it. So let's go. It says rearrange the equation so m is the independent variable. So this one's going to require a little more manipulation. So let me kind of shrink this down, kind of go over here and expand this out. Okay, cool. So when we're doing these problems, let me kind of move my little face over to this side. All right, that's better. And I'm going to hide this thing. Okay. And let's get rid of this thing too. All right, guys, now I think we're ready. All right, so with that being said, we're going to start here. And basically, all you have to do in these situations when you're doing function rules from equations is it says rearrange so the equation, rearrange the equation so m is the independent variable. So you're just trying to solve for m. So let me show you kind of what that looks like. You're going to go 7m plus 2 is equal to 7n minus 5. And it wants m to be the independent variable, right? So what that means basically is they want m to be independent. So that's the one that is the input, right? So that's like your input variable, right? So basically that means that you want ultimately n equals. So if n equals, right, then n is a function of m, and m is the independent variable, where n is the dependent variable, right? Just like y is the dependent variable when x is the independent variable, right? So y equals something times x would be a situation where y is dependent on x, right? Y is a function of x. In this case, you want m to be the independent variable, which means you want the isolated variable to be n. So you're basically solving for n, okay? So since you are solving for n, and that's your goal, you're going to start with 7m plus 2 equals 7n minus 5. And you're going to want to get the n all by itself. So you're going to want to isolate this variable term right here, 7n. Well, how do we do that, right? Well, we got to get rid of what's on the same side as that n term. So you got to get rid of minus 5. So how do you get rid of minus 5? You add positive 5 to both sides. Okay, whatever you do to one side, you always do to the other. What you have there then is 7m plus 7 is equal to 7n. You now want to get rid of the times by 7 because you don't want to know what 7n are worth. You want to know what n is worth, just n by itself. So how do you undo times by 7? You divide by 7. Now, when you divide the equation by 7, the whole equation by 7, you remember you're dividing this whole side by 7. So really, you got to divide all terms by 7. So you get 7 over 7, or 1 times m. And then you get plus 7 over 7, which is the same as plus 1. And that must be equal to 7 over 7 times n, or 1n. So ultimately, what we can see is when we isolate n, we have the value that n is equal to m plus 1. So that's how we can isolate n and make m the independent variable and n the dependent variable. So what does n equal? N equals m plus 1. M plus 1, so it doesn't make an error there. And that's how you do it. Okay, for the next one, we're trying to solve for m because we want n to be independent, which means we want m to be dependent. All right, so once again, we're going to go through that process. This time I'll be a little quicker because I think you guys have seen how to do it once. It makes it easier. So watch. 3m minus 2m equals 12. You want to solve for m. So what do we do there? Well, we want to combine our like terms. And this one's actually really easy because what is 3m minus 2m? That's just 1m, right? So that's the 1m we already have here. So that is m. So m does equal what? 12. So in this situation, literally, m is 12. That's all it is. So that's how you get it. It's not quite yet. What did I forget here? So it says rearrange the equation so n is the independent variable. Oh, that's funny. So I misread the second one there. It's not 2m, it's 2n. That's all. So I got to erase this here. Boop. Now you got to change that to n. And now we can solve. My bad. So first things first, read the letters carefully. Don't make a silly mistake like I just made. All right, let's go through and do it properly then. So we have 3m minus 2n is equal to 12. You want to get the m's by themselves. So how do you undo minus 2n? We add 2n to both sides. You notice these are not like terms, so you can't combine them. So what you get is 3m's is now equal to 2n plus 12. You want to get the value not of 3m's, but the value of 1m. You want to solve for m. So you're going to divide both sides by the coefficient of m, 3 in this case. When you divide the right side, you can divide all terms by 3. So what you end up with there is that m is equal to 2/3 of n plus 12 divided by 3, which is 4. So ultimately what you get is 2/3 of n plus 4. Okay? And so that's what you write here. So it's not 12, like I originally thought, because I thought that was both m terms. It's going to be 2/3, or 2/3. So I would do x over y, 2 on top, 3 on bottom, times the value of n, okay, and then plus 4. And that's going to be correct. Okay, and now let's go to the next one. So hopefully this time I can read it carefully and not make a silly mistake like I just made. So this one is going to be negative 5x minus 4y equals negative 8. It says you want to solve so x is the independent variable, which means you want to get y by itself. So y is the dependent variable. So we're trying to isolate the y. So you're trying to get this y all by itself. So what do you got to get rid of is that minus 5x. So how do you get rid of minus 5x? You add 5x to both sides. And notice that then you have negative 4y is equal to 5x minus 8. You then want to get rid of that times by negative 4 because you want to have the value of 1y and not negative 4y. So you divide the y term by the coefficient of y, negative 4. If you divide the left by that, you've got to divide the right side of the equation by that as well. So all terms are going to get divided by negative 4 across the entire equation. Negative 4 divided by negative 4 is positive 1. So then you get 1y, which is what you want. You want y to be the dependent variable, and you want it in terms of x, basically, right? So y equals 5 divided by negative 4 is the same as negative 5/4. So you can just leave it like that. That's perfectly fine. It's like negative 1.25, but you don't have to make it a decimal. Just leave it as negative 5/4 times x, okay? And then what are you adding to that? You have negative 8 divided by negative 4, so that's positive 2. So you're adding positive 2 or just plus 2. And that is your function where you solve for y as the dependent variable and x as the independent variable. And so now you just put that in. It's going to be negative the quantity of x over y, which is going to be 5/4. And then you're going to times that by the input x. And you're going to then add 2. Right? So it's the negative 5/4 times x and then plus 2. And last but not least, let's get rid of this and do the next one, which is going to be negative 12u plus 13 is equal to 8w minus 3. And so in this particular case, it says they want u to be the independent variable. So if u is the independent variable, that means that's what you're inputting, then you're going to output the dependent variable, which is going to be w. So that's why it has w equals. You're going to solve for w. So if you're trying to solve for w, you're trying to get this 8w by itself first. How do you get rid of minus 3? You add 3 to both sides. You can see that this is a zero pair. It goes away. You get negative 12u plus 13 plus 3, which is 16, is equal to 8w. You don't want the value of 8w. You want the value of 1w. So you divide both sides of your equation by the coefficient of w, which is 8. When you divide the left side, you're going to remember to divide all terms across the left side, both terms by that 8. So ultimately what you get is that w is equal to negative 12 over 8 times u, which is the same if you divide top and bottom by 4 as negative 3/2. So what you end up with is negative 3/2 times u, and then plus 16 over 8, which 16 over 8 is just 2. 16 divided by 8 is 2, so plus 2. So ultimately you get w is equal to negative 3/2 u plus 2. Let's put that in, and let's see what that's worth here, if we get the right answer. That's minus, and then the quantity of 3 over 2 times the input of u, the independent variable u, and then plus 2. That should give you the correct answer. And that's how you guys do it, right? So when you're solving for a particular variable, that thing you're solving for is called the dependent variable, and the thing that is written in terms of is the independent variable. All right, let's stop it there, and we're good to go.